Hello everyone, this is Mrs. Pierce and I am working through this is a review of vertices, edges, faces, and nets. This is actually prior to Chapter 1. In Chapter 1 there's going to be a lot of geometry and we're going to be working with surface areas and volumes of three-dimensional objects. So in order to make sure that we all understand what each piece of a three-dimensional object is, we're going to review some of these vocabulary terms from geometry. So the first vocabulary term that we're reviewing is a polyhedron. A polyhedron is basically a solid or three-dimensional solid that is bounded by polygons. They are also called faces. So a face is a flat surface. And use the words, says use the words in the essential question to fill in the blanks below. Okay, so here's our essential question up here. And it says, what is the relationship between the number of vertices, edges, and faces? Actually, I'm going to use green for the edges, and I'm going to use blue for the faces, because in a minute here we're going to be labeling one vertex red, an edge green, and a face blue. So basically, so in these sentences we need to figure out, well, is it a vertice, an edge, or a face? So is each blank, vertice, edge, or face a point formed by the intersection of something? Well, if it's a point, hopefully you know, is going to be a vertex. A vertex is a point. The next one says each blank is a segment. Well, if you look at your picture, a segment is going to be the edge. And then each blank is a portion of a plane. And since we've already used vertex and edge, hopefully you figured out that the third line is going to be for face. So these are the three things that we're looking at in our polyhedron. So let's fill in the rest of the blanks here. Each vertex is a point formed by the intersection of, well, hopefully in geometry you learned that a point is the intersection of three lines. Or three planes, sorry. A vertex is the intersection of three planes. And but in a polyhedron, we don't have a full plane. It's just a portion of a plane. So rather than saying that it's the intersection of three planes, we would say it's the intersection of three faces. You could also look at it as the intersection of three segments or lines. Maybe put or there. So if you look at the vertex here, if I'm going to label one vertex, there's a lot you can choose from. So I'm just going to use this one here. So I'm going to label that vertex and I'm going to call it a capital A, because points have to be labeled with capital letters. So if you look at that point, you can see that the three edges are all converging onto that point, but it also is the intersection of the three faces, the one that's on the right, the top, and the back side. Well, what about an edge? Each edge is a segment of a line that's formed by the intersection of two faces. So in geometry, again, you probably learned that when you have two planes that intersect, it forms a line. Well, again, instead of a plane, we have just a portion of a plane, a face. So when those two faces intersect, we have what we call an edge. So there's lots of edges you can choose from here. So just color one edge green. So if I color this edge green, hopefully you can see that's green. and this is called my edge. And this A is a vertex. And then the third thing we're to highlight is the face. So there's lots, again, there are 6 faces on this rectangular prism. So I'm just going to kind of shade in one of the faces on the right side here. And this is what we call a face. All right, and that's a polyhedron, or a 3-dimensional solid. This is actually a right prism, or rectangular prism, all above. Okay, so there's a couple things that we're going to be doing with the vertices, edges, and faces. And if we look at the directions here, they've got some other words here, Platonic solids. The tetrahedron, the octahedron, and the cube are examples of Platonic solids. And what makes it a Platonic solid is that each solid has congruent regular polygon faces. Well, what does that mean? Well, hopefully you know that congruent means that all the sides are the same. Regular, so all of the shapes, each of the faces, the angles are all the same measurement, the lengths are all the same, and of each face. So each flat side is representing a congruent regular polygon. So in each of these, you're supposed to complete this table. So in the tetrahedron, if you wanted to name how many vertices, edges, and faces it has, let's start with the vertices. And again, I'm going to use my same colors of red, green, and blue. So if I just highlight each of my vertices, so there's 1, 2, 3, and 4. So there are 4 vertices in my tetrahedron. If I look at my edges, I've got the one over here, the one here, and the one here. So that's 3 that are going down from the top vertex. And then the base is also made up of 3 edges. So the triangle at the bottom is also 3 edges. So there's going to be 1, 2, 3, 4, 5, 6. Oops, put it in the wrong spot. There's going to be 6 edges altogether. Okay. Then the last thing they're asking us to do is the faces. So if we look at each of the faces, you've got the one that's on the bottom, the one that's on the side, the left side. Then you've got this one that's, how to make it show this differently. This one here, that's kind of in the front right. And then you've also got the one in the back. Yeah, it's kind of hard to see all 4, but there's the bottom, and then there's 3 around, so it's actually going to be 4 faces. Okay, so next, try to do the octahedron. So find the number of vertices, edges, and faces. Take a minute to do that, and then we'll go over it together. All right, so as far as the vertices, I've counted 6. So you got the one at the top, the bottom, and then 4 around the middle. So that's 6 total. As far as the edges, I've got 4 coming down from the top, 4 around the outside, and another 4 coming up from the bottom. So that's 12 total. as far as the faces, now we're only looking at the outside faces, so you've got the 4 on the top and then the 4 on the bottom. So there are actually going to be 8 faces altogether. So hopefully you saw that. So right here, so this triangle, that triangle, the one that's in the back right, the one that's in the back left, and then you've got the 4 on the bottom also. And then the last one, not least, the cube. So take a minute to do the vertices and the edges and the faces, count them up. So I got 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges again. But then as far as the faces, you've got your left side, your right side, the top, the bottom, and then the front and the back. So there's going to be 6 faces altogether. All right, so that was just a quick review of vertices, edges, and faces. Pretty easy, hopefully. Now moving on to nets. Net is something that is basically taking those 3-dimensional objects and breaking them up into all of their polygons. So this is an example of a net. This is an example of a net. So a net is a 2-dimensional shape or 2-dimensional picture that when folded it will become a 3-dimensional shape. So there's a couple examples here. We're going to be asked to draw the solid represented by the net and then describe the solid. So you're going to be given a net and then you have to draw the solid. So some of our drawings, they don't have to be perfect, but just do your best. So to draw a cone, even though we know that this is a circle, in 3-dimensional, because it's 3-dimensional on a 2-dimensional piece of paper, you might find it easiest to do kind of like an oval and then make it dotted on the back side to show that that's behind it, and then make a point up above it and then bring these 2 lines on either side up. And then another good thing to draw in is your radius. So from the center of the circle on the bottom out to the side is your radius. Now they've given us a radius and they've given us a slanted height. This is not the perpendicular height, so that will be important when we try to find surface areas and volumes of cones in the next couple of sections. So again, looking at the directions, what they ask you to do, they ask you to draw the solid. So this is the drawing, and then describe the solid. So here is the description. So they would say the net forms a cone with a radius of 3 inches and a slant height of 5 inches. So that's what your descriptions should sound like also. The next example that they gave us kind of looks like a star, but if you look at the inside, you can see these little congruency marks, and if you count the number of sides, there are 5. So a 5-sided figure is called a pentagon, and because all of these marks say that they're congruent, it's going to be a regular pentagon. And then each of these triangles, when we bring them up to the center, will create a pyramid. So we've got all these triangles folded up, and this is what the drawing should look like. So the easiest way, again, if you had to draw something like this, start with this base here and then kind of go out, and then the dotted, and then pick a point. So whether it's a cone or a pyramid, draw the base, then pick a point up here, and then just kind of draw each of these line segments going up to that vertex that's at the top. And the description then, the net forms a regular pentagonal, regular again because it's all congruent, pentagonal because it's the 5-sided, pyramid. So a pyramid only has 1 base, and a cone only has 1 base. A prism has 2 congruent bases. And it's got a slanted height also of 12 centimeters. So they showed us that 12 centimeters there, so we're going to include that in our description. So we have 3 problems for us to do. So let's start with this one. So you're given the net. You have to draw the 3-dimensional solid. So if we look at this picture, they're not exactly the same as what we had before. So it's not going to be a cone or a pyramid. But if you look at the picture, you can see that on the top and the bottom, it looks like we have 2 triangles that are congruent, which is probably going to be a prism, because a prism has 2 congruent bases, one at the top and bottom, or left and right, and then around the prism you always have rectangles. So these are 3 different shaped rectangles, or actually this one's a square, and then you've got 2 triangles that are the same. All right, so now we have to figure out how we're going to draw this. So I'm going to start with this long side of the triangle, and I'm going to make it horizontal. So this is going to be my hypotenuse, and then the 2 legs of the triangle, I'm going to kind of make them look 3-dimensional, kind of like that. So there's my right angle. And then because it is a prism, I'm going to have another rectangle or triangle that is the same. So this horizontal line, I'm going to draw another horizontal line and then make my triangle again look kind of 3-dimensional. But I want it to be right above the other one. So I'm going to have my 2 congruent triangles right above each other. Now I'm going to connect my edges. So from this vertex to this vertex, there's one edge. From this vertex to this vertex, there's another edge. And then the one in the back, I'm going to make it a dotted line so that it looks like it's not seen. So now we have a triangular prism. But what's special about it is it's not just a triangular prism, it's a right triangular prism. So, they also give us some dimensions here. So this 3 meters is the shorter leg, the 4 is the longer leg, and the 5 is going to be your height. Now we don't have to put there's a lot going on here, so I would just say the net forms a right triangular prism. So we've got a right triangular prism that has a height, or with a height of 5 meters. The idea here is just basically, can you take that net and describe and draw the 3-dimensional object and describe what it is to the best of your ability. So I would expect you to say something like the net forms a right triangular prism. The 3 and the 4, I guess, you could say that has a length and width, or, but that's actually not necessary. We'll just say a perpendicular height of 5 meters and call it a day. All right, let's go on to number 2. So this section is also, this part, additional topic is also just kind of getting you familiar with all your shapes and names of all these shapes and 3-dimensional objects again. Okay, so this one here, in example 2, again, does not look like either one of the examples that we had to begin with, but it does have 2 circles on the top and the bottom, and it has a rectangle in the middle. So this is actually a net for a cylinder. So a cylinder, when you're drawing a 3-dimensional cylinder, you're going to have you're going to want to draw an oval to show the 3-dimensional circle, but then you're going to have one above, one on the bottom, and one on the top, kind of like this cone. We had an oval, but if we had a cylinder, we have to have 2 ovals right above each other. So off to the space here, off in the space over here, let's do our best. Maybe use pencil or erasable pen. So I'm going to draw my half circle, and then I'm going to draw this dotted line for the back of it, and then up above it I'm going to draw another circle, half of an oval, and then actually the back side, since it's the top, it will be seen. And then I'm going to connect each of the edges here. So there's, looks like my cylinder, my soup can, and then I'm going to draw my radius from the center out. And I've also got one from here out, and the radius is 5 feet, and then it's also got a height of 6 feet. So those two dimensions are pretty easy to write in. So the net forms a cylinder. And you might want to say it's a right cylinder because these are, it's going to form a right angle here between the radius and the height. But just cylinder's fine for now. With a radius of 5 feet and a height of 6 feet. So that's how we would write our description. So it forms a cylinder with a radius of 5 feet and a height of 6 feet. And there will be other things in this chapter that you will have to be describing. So this is also good practice for what's coming up. Last but not least, we have a square here. It looks like a square because we have our congruency marks. And then we have these triangles. So we've only got one base and we got triangles around the outside. So if we look at the example B, we had something similar, but instead of a square, we had a pentagon with the triangles around the outside, and it formed a pyramid. So this problem is also going to form a pyramid. Again, this one's kind of hard to draw, so follow along with me. I'm going to start by trying to draw the square, but I'm going to try to draw it two-dimensionally. So I'm going to start with a horizontal line, and then to show that it's going back diagonally like this, I'll make this one dotted because it's in the back, and like that. So this is my square, and three-dimensionally it looks like a rhombus, but it's, I think, supposed to be a square because this is perpendicular. Then we've got, I'm going to put a point kind of at the top for the tip of my pyramid, and then I'm going to draw the edges of each vertex coming up to that point. So that's not too bad. So that's my three-dimensional pyramid. So this forms a square pyramid with we've got a couple things going on. So this 6 millimeters, when we fold it up, it's going to actually be on the slanted height. So it's going to have a slant height of 6 millimeters. And the square has sides of 8 millimeters. So I'm going to say, and the square has, and the square base has sides that are 8 millimeters. Okay, so again, this was just an additional topic that we kind of put in to get you familiar with some of these three-dimensional shapes and the nets and the edges and the faces and the vertices and all those good geometric terms that you need to know for the rest of this chapter. And that's the end of these notes.